Hi everyone, in this chapter of the book, we're going to be talking about descriptive statistics. But before that, let's go over some definitions. First of all, we need to know what a population is and what's a sample. We've already talked about this a little bit in class, but the population is a set of all elements of interest in a particular study, whereas sample is a subset of the population that is representative of the population. Let me give you an example. I would like to learn what USD undergraduate students think about our campus's dining halls. So the population of this study is all undergraduate students at USD. There's about 5,700 students at USD. Then I take a sample of 500 undergraduate students at USD and I select my sample randomly. So my population is every single undergraduate student, which is 5,700, but my sample is a subset of that, which is the 500 randomly selected students. A statistical inference is the process of using data obtained from a sample to make estimates and to test hypotheses to infer conclusions about the characteristics of the population. So the population characteristics are called parameters, whereas sample characteristics are called statistics. If we have a good sample, we would expect the sample statistics to be an unbiased estimator of the population parameter. We are interested in estimating the true average number of credit hours taken by USD undergraduate student population this semester. So we collect a simple random sample of 100 students and we ask each one of these students in the sample about the number of credit hours they're taking this semester. Sample data shows an average of 15.42 credit hours with a standard deviation of 1.45 and a median of 16. Now the sample average that I just reported is referred to as an estimator. An estimator is a particular example of a statistic, which becomes an estimate when the formula is replaced with actual observed sample values. So you all know how to calculate the average. You add up all the numbers, divide by the total number of observations. That formula, that average formula, is what we call the estimator for average or mean. But then after you plug in numbers into your formula and you calculate a number, the number that you've calculated is called the estimate. So sample median, sample standard deviation for credit hours, these are also called estimators. Now the number 15.42 that I calculated based off of my sample is referred to as a point estimation. A point estimation is a single value that estimates the parameter. The numbers 16 for the median and 1.41 for the standard deviation that I also reported from my sample are called point estimators. Now, how do we describe a data series? We have n observations. Then we have xi, which is the value for the ith observation. And therefore, we have x1, x2, x3, all the way to xn, which is our data set. So this is how we describe a data set. We have n observations, xi values for each one of the observations, and the set of all of the values, all of the xi's from x1 all the way to xn is our data set. Now, if your data is small, so if the number of observations is low, it is easy to describe the data. You may even be able to just look at the data and say something about it. But when n is large, then how do we describe the data? Let's look at an example. So the table I've got here, on the first column, I have class number, and then on the second column, I have class size. So let's consider this data on class size across 35 classes at USD. So you can see the class number is just an index that identifies which class we're talking about. So the first row, which has a class number of 1, has a class size of 24. That means there are 24 students in class number 1. Then there are 30 students in class number 2, 25 students in class number 3, and so on. So the elements in this study are the classes, because we are obtaining our data on classes. The number of observations is 35 because we have 35 classes in here. Now, what is the value for the first observation? The class size for the first observation is 24. That means x1 is 24. What's the value for the second observation? The value or the class size for the second observation is 30. Now, what's the value for the 35th observation? That is 40. So, like we said in chapter 1, data can be categorical or quantitative. Examples of categorical data are gender, race, ethnicity, colors, and examples of quantitative data are income, temperature, time, weight, and height. Depending on the type of data we have different ways of describing or presenting the data. And that's what we're going to be talking about for the rest of this chapter.